Hello everybody and welcome to the video notes for Unit 5, Day 2, and today we are learning about something called histograms. For most of this unit, we're going to be working with different types of data representations. So at the top of your paper, I want you to write the word data. D-A-T-A, data. And what data means is it is a set of numbers for information. A set of numbers that you use for information. Let's read this problem here. The Lionel Wilson soccer team is raising money by selling baseball caps. The following data set represents the head circumferences in millimeters of everyone who ordered a hat. Their circumference around your head, what that means is the distance all the way around your head. So the larger the head circumference you have, the larger the head you have. And first, before I continue, today's notes are dedicated to Yair in 6C. Yesterday's was also dedicated to Yair, but I wrote it down but I forgot to say it. So here's one more. Hi, Yair. Here's our data set, right? This is a set of numbers for information. This is our information right here. All of these represent different head circumferences, how big your head is. And then below is a chart that shows what size hat you should order based on your head size. Use this data to complete the table. We have cap sizes. They're extra smalls all the way up to extra, extra large. And then there are interval of head circumferences. I want you to underline this word interval. And above, we're going to write interval. And what that means, an interval is a number range. So from like 1 to 5, that's an example of an interval. Or everything from 50 to 100, that's another example of an interval, a number range. So the first interval is from 510 millimeters to, remember this is the less than symbol, to everything less than 530. If that's how big your head is, then the right size for you is an extra small. So what you can do is you go back to this data set up here and count how many numbers are within this interval range from 510 to less than 530. Let's start here. 513, okay, that's between 510 and 530. That's one tally mark. 525. That's between 510 and 530, so another tally mark. And then the next number is 531. 531 is not between 510 and 530, so I'm not going to put it in this interval. Instead, it goes to the next interval, which is 532, everything less than 550. So 531 would go in this number range. So since there were only 2 tallies for the extra small, for frequency, remember frequency is how often it happens twice. So I can put the number 2 right there. Now let's keep going. 533, that's between this range right here, 530 to 550. So I'll cross that out, put another tally here. 535, that's also between 530 and 550. I'll cross that out. Put another tally mark, another 535, that's going to go here too. 542, that's in this between 530 and 550, that will go here also. Now I have 5 so far. 543, yep. So everything less than 550 is going to go in this range right here. 546, okay. 549, yep. and then 551. 551 is not less than 550, so that's going to go in this range, which is 550 to everything less than 570. And now there's there's 5 here, and then another 3 here, so 8 tallies total for smalls. Okay, and then you just keep going with each of these number ranges, tallying it up, and then making a frequency. That's all I'm going to do for you, and then you're going to fill out the rest of this on your own. So first, what you can do is pause, and then finish this frequency table based off of what you see up here. And now you are resuming the video to move on to the part after this is done to make your histogram. So next to where it says create a histogram, I want you to write this. I want you to write a data plot. That's what we did yesterday. A data plot uses individual numbers. A data plot, you might see like 1, 2, 3, 4, like that. Whereas a histogram, so let's write histogram. A histogram, instead of using individual numbers, it uses intervals. And if you need to look back, what is an interval? An interval is, what we wrote up here, a number range. So instead of it being 1, 2, 3, and 4, and how many for 1, how many for 2, how many for 3, and how many for 4, it would be how many that are in between 1 and 5, like that. Like you did up here, these are all intervals. Histograms use intervals. Dot plots use individual numbers. Here's how you would create your histogram. For head circumferences, that's on the bottom here, we have the range 510 to everything less than 530. This number range right here is this number range right here. And how many people were in this number range? 2. So that's why on this graph you see frequencies on the left. Here is the frequency for 2. You draw a rectangle going up to 2, just like that. The next number range is 530 to 550, which is this number range right here, 530 to 550. What was the frequency for smalls? It was 8. 8 people were in this range of 530 to everything less than 550. So that's why on this graph, between 530 and 550, it goes all the way up to 8. You draw the rectangle up like that, and you can shade it in if you want to. So then the next number range would be 550 to 570, and you would look up here, that was size medium. How many people were in between the range 550 and 570? That's how high you'll draw up your rectangle right here. Then, once you are done creating this histogram, you can answer each of these questions, right? Where is the center? Right? It should form a little bit of a hill. Where is the center of the hill? That's what would go here. Here it asks you if 2 more people ordered hats and they were 551 and 569, how would that change your histogram? And then change your histogram. And then last one, what is one difference between a dot plot and a histogram? Well, as a hint, I may have already given you the answer up here. All right, so that's this. One last thing is I'm going to go to page 3 now. there are three different types of histogram shapes. The first shape is something that's called symmetrical. This is an example of a histogram that is symmetrical. And if something is symmetrical, it means it's that the data is even on the left and the right. So if it's even on the left and on the right. Notice how on the left side, it's about the same shape as it is on the right side. So that's why it's symmetrical. If it's not even on the left and even on the right, it might be something called skewed left. This is the example of a shape of something that is skewed left. If something is skewed left, it's because there is less data on the left and more on the right. So you see how in this graph, most of the data is on the right side and there's less on the left. It's kind of more empty on the left. That's when we say it's skewed left, when there's less on the left. Less on the left. The other shape is, if you notice on this one, all of the data is kind of on the left side and there's less on the right. So if it's skewed right, it means that there's less on the right. And there's more data on the left. Okay, so these are a little bit tricky because it's the side that there's less on. So if it's skewed left, it means there's less on the left, more blank space on the left. If it's skewed right, it means there's less data on the right. There's more blank space on the right. Okay, so now that you know these three terms and what they look like, you should be able to answer the rest of this page. And with that,
thank you so much for playing my game.